Hey guys, in this video we will be going over the square root property and completing the square. So recall that a quadratic equation can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. So for example, x squared minus 3x minus 40 equals 0 is an example of a quadratic equation. And we can solve quadratic equations by first factoring and then using the zero product rule. So the left side factors to x minus 8 times x plus 5. And then we set each factor equal to 0 and solve for x. We get x equals 8 and x equals negative 5 as solutions. However, it's not easy to solve all quadratic equations by factoring. Therefore, we need to learn other methods. Let's begin with the square root property. So let k be a constant. If we have x squared equals k, then x equals plus or minus the square root of k. This can also be written as x equals the positive square root of k, or x equals the negative square root of k. So for example, let's look at the equation x squared equals 9. We can solve this by first getting it into standard form and then factoring. This gives us x equals negative 3 and x equals 3 as solutions. Or we could also solve this using the square root property, and taking the square root of both sides will cancel out the square term. But we make sure to include the plus or minus sign on the right side. So the square root of 9 is 3, and we can split this into two equations, and we get the same two solutions, x equals 3 or x equals negative 3. It's important to note that we can use this property when we are solving an equation containing a squared quantity with a variable on one side and a constant on the other side. So let's try a few examples. We want to solve the following equation using the square root property. Notice that this binomial can't be factored since it is not a difference of squares. However, we can rewrite this so that we have a squared quantity on one side equal to a constant. So we add 20 to both sides. And now that we have a squared quantity on one side and a constant on the other, we can apply the square root property and take the square root of both sides of the equation. This cancels out the square on the left side, and we get plus or minus square root of 20 on the right. And make sure to simplify the square root. We can factor out a square root 4, which gives us plus or minus 2 square root 5. So now our two solutions for x are 2 square root 5 and negative 2 square root 5. Or if you want, you could just leave it in the form plus or minus 2 square root 5. For the next equation, first we need to rewrite it so that we have a squared quantity on one side and a constant on the other side. So we subtract 21 from both sides of the equation and then divide both sides by 2. And now that we have a squared quantity on one side and a constant on the other, we can use the square root property and then take the square root of both sides. This cancels out the square on the left side, and we get plus or minus the square root of negative 9 on the right side. We can then simplify the radical, and we're going to have a complex number as a solution since we have a negative radicand for the square root. So simplifying this will give us plus or minus I times 3, which is the same as plus or minus 3i. And our two solutions for x are positive 3i and negative 3i. And again, you can just leave it as plus or minus 3i. So we can also solve equations in the form ax plus b quantity squared equals k, a constant, using the square root property. And we can do this because we have a squared quantity on one side and a constant on the other side. So for example 2, we want to solve the following equation using the square root property. Since the equation has a squared quantity on one side and a constant on the other side, we can use the square root property to take the square root of both sides of the equation. This cancels out the square on the left side, and we have plus or minus the square root of 25 on the right side. The square root of 25 is 5, so we have plus or minus 5 on this side. And now we just have to isolate the variable, so we add 4 to both sides. And let's write this so that the plus or minus term is written at the end. And now that we have our variable isolated, let's write this as two separate equations because it looks like it can be further simplified. And our two solutions for x are positive 9 and negative 1. For the next equation, again, since we have a squared quantity on one side and a constant on the other side, we can use a square root property. So this will give us 2x minus 5 equals plus or minus square root 12. So the square root of 12 simplifies to 2 square root 3, and now we need to isolate the variable, so we add 5 to both sides, and then divide by 2. And then we get x equals 5 plus 2 square root 3 over 2 as one solution, and x equals 5 minus 2 square root 3 over 2 as the other. And again, we can write this as 5 plus or minus 2 square root 3 over 2 as our solution. And then for this equation, first we need to get it so that we have a squared quantity on one side and a constant on the other side. So we can subtract 11 from both sides, and we have x plus 8 equals plus or minus square root of negative 4. We can simplify the square root of negative 4 as 2i, and then now we have to isolate our x. So we subtract 8 from both sides of the equation, and we have x equals negative 8 plus 2i, or x equals negative 8 minus 2i. So our solutions are negative 8 plus or minus 2i. Okay, so the next method we will learn for solving quadratic equations is completing the square. So recall that when we square a binomial, like x minus 4 quantity squared, we can write this as x minus 4 times x minus 4, which equals x squared minus 8x plus 16. And we call this product a perfect square trinomial since it can be written as a square when factoring. Okay, so let's say we have x squared plus 10x plus 25. This is considered a perfect square trinomial since it can be factored as x plus 5 times x plus 5, which is x plus 5 quantity squared. But what if instead we were just given x squared plus 10x, and we had to find the constant term that will make this a perfect square trinomial? To find the constant needed to complete the square, we take half of the coefficient of x, so half of 10, and then we square this value, so we have 5 squared, which is 25. And adding this constant to the expression is called completing the square of x squared plus 10x. So let's write this procedure down. In order to complete the square for an expression of the form x squared plus bx, first we would find half of the coefficient of x, so b over 2, and then square the result. And then we add this to the end of our expression to get x squared plus bx plus b over 2 quantity squared, which is a perfect square trinomial that will factor to x plus b over 2 times x plus b over 2, which is just x plus b over 2 quantity squared. So let's practice completing the square on some expressions. In order to complete the square for this expression, we need to find the constant term that we add to this that will make this a perfect square trinomial. First, we take half of the coefficient of x, so 6 over 2, and then we square this quantity. This will give us 3 squared, which is just 9. Therefore, adding 9 to this expression will complete the square. And this factors to x plus 3 times x plus 3, which is the same as x plus 3 quantity squared. To make this next expression a perfect square trinomial, we need to complete the square by adding negative 14 over 2 quantity squared, which is 49. So adding 49 to this expression will complete the square, and this factors to x minus 7 times x minus 7, which is the same as x minus 7 quantity squared. So now that we know how to complete the square, we can apply this method to solving quadratic equations. So if we have a quadratic equation like x squared plus 6x equals negative 3, We won't be able to use a square root property on this right away, since we don't have a square term equal to just a constant. And notice that if we write this quadratic equation in standard form, we can't factor the left side. Therefore, we will use completing the square to solve this instead. So we want to complete the square for x squared plus 6x in order to make this a perfect square trinomial. And the constant that will make this a perfect square trinomial is 6/2 quantity squared, which gives us 9. Therefore, adding 9 to this expression will complete the square and make this a perfect square trinomial. And since we're adding 9 to one side of the equation, we must also add it to the other side. We need to keep the equation balanced. Now the left side factors to x plus 3 quantity squared, and the right side equals 6. And now that we have a squared quantity on one side and a constant on the other, we can use the square root property and take the square root of both sides. So this removes a square on the left side, and we have plus or minus the square root of 6 on the right side. And now to solve for x, we subtract 3 from both sides. So we have x equals -3 plus square root 6, or x equals -3 minus square root 6 as our solutions, which is the same as saying that our solutions are -3 plus or minus square root 6. Okay, so let's write down this procedure for solving quadratic equations by completing the square. To solve an equation of the following form by completing the square, first the coefficient of the square term must be 1, so a has to equal 1. If it is not 1, then divide both sides of the equation by a to obtain a leading coefficient of 1. Next, we would get the variables on one side of the equal sign and the constant on the other. And then we could complete the square. We add b/2 quantity squared to both sides of the equation. Then we factor, and then we solve using the square root property. So let's try a couple more examples. We want to solve the following equation by completing the square. Now, you could solve this quadratic equation by factoring and then using the zero product rule, which will eventually give us x equals -4 and x equals -2 as solutions. But let's solve this by using completing the square instead. So the coefficient of the quadratic term x squared is 1, so this condition is satisfied. And we also have our variables on one side and the constant on the other. So now to complete the square, we're going to add b/2 quantity squared to both sides. So 6/2 quantity squared, which is 9. And now we have a perfect square trinomial on the left side, which can be factored as x plus 3 times x plus 3, or x plus 3 quantity squared. And now that we have a squared quantity on one side and a constant on the other, we can use the square root property and take the square root of both sides. This cancels out the square on the left side, and the square root of 1 is just 1. Then to solve for x, we subtract 3 from both sides, and we have x equals -3 plus or minus 1. Splitting this up into two equations, we have x equals -2 and x equals -4 as solutions. For the next example, the coefficient of the quadratic term x squared is 1, so this condition is satisfied. The next step is to get the variables on one side of the equal sign and the constant on the other side. So we subtract 14 from both sides of the equation. And now we can complete the square by adding -10/2 quantity squared to both sides of the equation. This will give us 25. So we add 25 to both sides of the equation. And now we have a perfect square trinomial on the left side, which factors to x minus 5 times x minus 5, or x minus 5 quantity squared, and the right side equals 11. We use the square root property and take the square root of both sides, and this cancels out the square on the left, and on the right side we have plus or minus the square root of 11. Then solving for x, we add 5 to both sides of the equation. This will give us 5 plus square root of 11 and 5 minus square root of 11. Therefore, our solution set is 5 plus or minus square root 11. For this equation, first let's rewrite this in descending order of degree. And now in order to complete the square, we need our leading coefficient to be 1. So to do so, we will divide both sides of the equation by 4, and this will give us x squared plus 3x equals -6. Now we need to complete the square by adding 3 over 2 quantity squared, which is 9 over 4. And now this will be a perfect square trinomial. However, it might be a little tricky to see what this factors to, but since this is a perfect square trinomial, this will always factor to x plus b over 2 times x plus b over 2, which is the same as x plus b over 2 quantity squared. So our perfect square trinomial factors to x plus 3 over 2 quantity squared. And now we have to simplify the right side. So to add -6 plus 9 over 4, we rewrite it with the LCD of 4, and we get -15 over 4 on the right side. Now we can use the square root property and take the square root of both sides. This will cancel out the square on the left side, and we have plus or minus the square root of -15 over 4 on the right side. The radical will simplify to I times the square root of 15 over 2. And then to solve for x, we subtract 3 over 2 from both sides. So x equals -3 plus I square root 15 over 2, or x equals -3 minus I square root 15 over 2, which is the same as saying our solutions are -3 plus or minus I square root 15 over 2.